Alright, Algebra 1 students, this is our second factoring video, my favorite F word of Algebra 1. And we're going to be looking at polynomials of this format right here, which, if you read it across, is ax squared plus bx plus c. And in these problems, a is not equal to 1. It's also not equal to 0, but if it was equal to 0, that wouldn't make any sense anyway, because you wouldn't be able to factor something, because you wouldn't have an x squared term. But anyway, so this is a different polynomial. So what we're talking about is something that looks like what we have up here, which if you look up here, you got 2x squareds. You know your area models by now. 2x squared, 1, 2, 3, 4, 5, 6, 7x, and 6. And it's the product of, you can see the factors across the, down the side, x plus 2, down the side right here, x plus 2, and then 2x plus, ooh, I did not mean to do that. Let's fix that real quick. Okay. 2x plus 3, so 2x plus 3. So in these problems, we're looking at ones where your x squared has a coefficient other than 1. So my first question is, so why can't I just use the methods that we learned in the last video? Well, the method we learned in the last video tells me to find factors of c, which in this case is 1, that add up to b, which is 3. Well, the number 1 only has 2 factors, 1 times 1. Well, 1 plus 1 is definitely not equal to 3. 1 plus 1 is not equal to 3. So you would conclude from what we learned last time that you can't factor this. And what we learned is that if you can't factor it, it's, quote, prime, unquote, like a prime number, which only has 2 factors, 1 in itself. With a prime polynomial, we're saying that you cannot factor it. You can't write it as those 2 binomials. But that's not the case with this problem, because actually I can factor this. I recognize that this is 2x plus 1 times x plus 1. And you can see that if you use FOIL or distributive property, whatever, that 2x times x is 2x squared. 2x times 1 is 2x, 1 times x is x, and 1 times 1 is 1, and when you add up those two, the 2x and the 1x in the middle, you get 3x. So clearly it can be factored. So if I can't use the C and B method, what the heck am I supposed to do? Well, you're going to work backwards. And we're going to start with working backwards using the table method. So we work backwards using the table method. What we're going to do is we're going to find factors, all right, just like we did before, but what we're going to find is factors of AC, A times C, that have a sum of B. So, AC is 2 times 1, which equals 2. B is 3. So we need to find factors of 2 that add up to 3. And the only factors of the number 2 happen to be 1 times 2, and they do happen to add up to 3. Yay! Okay, so what do we do with that? Well, what you're going to do next is you're going to split up that middle term. You're going to break it into your 2 factors. So 3x becomes 2x plus 1x. 2x plus 1x. And what am I going to do with my 2x plus 1x? Well, I'm going to go ahead and put the numbers into the table. So what I'm going to do is put the quadratic term here. Here's my 2x squared. Constant term here, positive 1. And then the other 2 blocks, doesn't matter which one is which, gets your broken up linear term, that middle term. So what we're doing is we're sort of recreating the FOIL products that you have if you had done this out, or the table products, in fact, if you had done it out as a table. And the last step is that you're going to find the GCF of every row and column, going up and going across. So let's do that. The GCF going up this far right column, well, 2x and 1 only have the number 1 in common, and it is a positive 1 because neither of them are negative. Let's see, here we got these 2 have x in common, 2 and 1, so no numerical value, but x in common. Here, 2 and x in common. And finally, 1 and x, positive 1 in common. And so we can see that our factors are indeed across the top and down the side. So the factored form of the trinomial we started with is 2x plus 1 and x plus 1. Let's try that again with another problem, maybe one that involves some negatives. Always remember to go through and double check it backwards. We already did that with this problem because we looked at it on the last slide. But we'll do it the next time, I promise. Okay, now you try this method. Pause it and try it if you think you got it. If not, just watch with me and we're going to do it out. Start with AC, which in this case is 3 times negative 5, which is negative 15. Now consider B. B is 2. We need factors of negative 15 that add up to 2. Well, the number 15 only really has 2 pairs of factors, 1 and 15 and 3 and 5. If we're thinking of negative, then you switch back and forth between having one negative and one positive. Or you think about what we talked about in the last video and you think about factors of 15 that have a difference of 2. But look here, we've got them. We've got this. Here it is right here. Okay, so you got your 2 numbers. Now we split apart our table, put quadratic term here, constant term here, use our 2 numbers to break up that middle term here. So that's going to be negative 3x and positive 5x. So now we're going to find our GCF, going straight up and going from right to left. So the GCF of 3x squared and 3x, well, they got 3 in common and they both have an x in common. So the GCF there is going to be 3x. Okay, now look here. So we haven't done too many of these. This is a good chance to talk about GCF a little as well as actually factoring this. Look at the numbers first. Think about the 2 numbers. If you see something as simple as this, then 5 is the GCF. Then remember to look at the variable. Yes variable, no variable. Can't have a variable in your GCF. Going up the left-hand side here, what do they have in common? Well, it's 3 and 5. They're both prime, so there's definitely an x in common. And then here, these 2 are both negative. Now, what you're going to do with negatives is if the top or if the top of the column, the top one of the column or the first one of the row is a negative, you're going to factor out a negative. So in this one, since it's negative 3x, we are going to go ahead and factor out a minus something. Well, 3 and 5 are prime, so it's a minus 1. You're factoring out a minus 1 there. And so we get 3x plus 5 and x minus 1. And when you FOIL that out, you have 3x times x, 3x squared, minus 1x plus, minus 3x plus 5x. And that will cancel out. So let's write it out. So 3x squared is our first product. Outer, negative 3x or minus 3x. Inner, plus 5x. And that's going to have the desired sum of positive 2x in the middle. And we do indeed get the same thing we started with. Now remember, when you go back and you check it, this is your check. This is your answer. Okay, not this, this. Okay, not like that. I want to see you actually write it the way that you would see it on a test or a quiz or the dreaded SOL. Now let's look at factor by grouping. This is one of my favorite things to teach because it takes something you learned last week and literally does it in reverse. I really think it's neat. Well, I guess that's kind of what we just did with the other one, but still. Okay, so factor by grouping, this is great. So in this case, you got 4 terms. And what you're going to do with your 4 terms is you're going to look at the first pair of terms and the second pair of terms. You're grouping them. You're grouping them together. And you're going to look for the GCF of each pair of terms. So, what's the GCF of this first pair? We got AB and BC. Well, they have a B in common. Look at this one, AD, CD. They have a D in common. The next thing you do with your GCF is you're going to factor it out. You're going to factor it out of each pair of terms. So for the first one, you're going to factor out the B, and it leaves A plus C. Sorry, folks, I was interrupted by a small child. Where the heck was I? Okay, so we took the GCF out of this one. That was B. Now we're going to take the GCF out of the other one. And that is D, so we're factoring out a positive D. Everything's positive here. Well, look what it leaves. If you factor out D, you're dividing a D out of both of these. It leaves A plus C. Oh, well, that's significant. That looks a lot like halfway through multiplying with the distributive property. So this is now something that you can factor one more time. Look what you have. You have B times the quantity A plus C plus D times the quantity A plus C. And what you can do with that is say that it's the same thing as B plus D together times the quantity A plus C. So you've got the two binomials, and if we multiply that out, we will see that it will give us that same polynomial we had in the first place. That same expression, we should say, in the first place. So let's do this out. And look at that, it's exactly the same, except, well, okay, so not exactly the same because I totally wrote that last part out of order. We'll fix it real quick. But that's factor by grouping. Now let's try it with a problem where you aren't given 4 terms, you have to find your 4 terms. And I bet some of you have already figured out how we're going to find those 4 terms. So here we're going to do 2x squared plus 5x plus 3. So let's start with, again, like we did before, just like we did before. We're going to find factors of AC that add up to B. And our factors, our AC here is 2 times 3, which is 6, and B is 5. So factors of 6 that add up to 5. They're both positive, so we are looking for the numbers 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. And that's what we're trying to use. So what you're going to do is you're going to take your polynomial. You're going to write it, keep the front end. You're going to keep the back end. You're going to break apart that middle term using those 2 numbers you just found. So now you have your 4 FOIL products. Your 4 FOIL products. So now go through and do your method of factor by grouping. So that's look at the first pair, look at the second pair. Take out the GCF. GCF of this first pair is 2x. And if I factor that out, it leaves x plus 1. Factor the second pair, GCF, the greatest common factor of the second pair, is 3, leaving me again x plus 1. And one of the great self-checking things about this method is that this set of parentheses has to match this one. In order for this to work, they have to match. And the last step is to take that duplicate set of parentheses and write that once, and the 2x plus 3, write that a second time, keeping in mind that it wouldn't matter if I wrote this one first and put it ahead of the other one, because the commutative property says either way, same product. All right, double check. We'll do that for you, double check. Yep, we got it. We got our 2x squared, we got our 5x, we got our 3. Another problem. Okay, you pause this one. You try it yourself. You come back and you watch. I will go ahead straight on barreling through. So AC, 3 times -2, -6. B, +1. Factors of -6 that add up to +1. We really need to know our integer math here. So it's factors of 6 that have a difference of 1, and you make the bigger absolute value number positive. So the factors of 6 that have a difference of 1 are 2 and 3. Make it -2 plus 3, and you get your +1. There's my 2 numbers. Keep the front end. Keep the back end. Break apart the middle term. And if you look, -2x plus 3x is indeed 1x. Now you're going to GCF it. By that sounded kind of goofy. By that I mean you're going to find the GCF of each pair of terms. So the first one is x, leaving 3x minus 2. And the second one, well, they don't have anything in common, so you're going to put a 1 there, leaving 3x minus 2. Making your 2 products, x plus 1 and 3x minus 2. If you just heard a jingling noise in the video, that was the cat running and probably trying to be difficult and make me mad, but it didn't work. Can't get mad at something so cute. All right, this time I'm going to pause it and write it out so we're not taking up making it a super duper long video. Yep, that's that. All right. So let's look at this one. Once again, pause it, try it. All right. This time, let's see. I'm kind of getting sick of some of these colors. I need something new. Let's try this one. AC, oh, that's different, is negative 28. B is negative 3. Factors of negative 28 that add to negative 3 are going to be, well, again, so we're finding factors of 28 that have a difference of 3, making the bigger absolute value positive. Well, the first ones, for me, that come to mind is 7 and 4, because I know they're kind of close together, about 3 apart. You know, in your mind, you're thinking of this quickly, so you might think of, oh, that's close, that might be it. Oh, yeah, that's it. Negative 7 and 4. So it should be that quick. Okay, if you need times table practice, you know where to go. Keep the front end. Keep the back end. Break apart the middle term. Okay, so GCF of the first pair and the second pair. Let's switch colors. Let's see. Let's find another interesting color. How about this? Oh, that's pretty bright. Oh, that's okay. All right, what do these have in common? An x. And when you factor out the x, you leave 4x minus 7. This has in common a positive 1, leaving 4x minus 7. This was not the best example because this is really similar to the last one. I should have noticed that. Final answer, x plus 1, 4x minus 7. This is a great candidate for IXL practice, guys. I believe I said in the homework post that that's topic AA under Algebra 1 is the one you want to look for. Having a heck of a time keeping my music on tonight, so I'll just have to leave it off. Okay, what else we got? I can't even remember what's on the next slide. Yes, how to recognize a perfect square trinomial. So we had this pattern, we learned this pattern a little bit in the previous video, and you notice again that we have the same, probably about the same thing I had written out in the previous video. It's your basic square binomial, so square sum, square difference. So remember that means we FOIL it out, and when we do that we get this pattern, a squared plus 2ab plus b squared, or this pattern, a squared minus 2ab plus b squared for this one. Noticing that the b squared is always positive, so is the a squared, and the middle term is 2 times the product of the square root of this and the square root of that. Let's think about that real quick. The square root of a squared is what times itself as a squared, that's a. And the square root of b squared, that's what times itself as b squared, that's b. So again, saying this again, this is 2 times the square root of the first term times the square root of the last term. Or in this one, because it's a difference, it's minus 2ab. So we want to be able to recognize that something is a perfect square trinomial. Sorry, the Velcro on my iPad case just got stuck to me. We want to be able to recognize that it is, because it makes it a lot faster to factor it. You just find that it's the square root of 2 terms, that's it. So let's look at some examples. So is it a perfect square? And you have 2 examples here. You have 4x squared minus 12x plus 9 and 16x squared plus 16x plus 1. So what are we going to do? Well, we're going to start off by saying, is this first term, is that a perfect square? Yes, yes it is. In this case it's 2x. How about this last term? Is that a perfect square? Yes, yes it is. In this case it's 3. So the middle term is that 2 times the product of those square roots. Doesn't matter if it's plus or minus over here, that's just going to determine this last part. But is that true? Well, 2 times 2 is 4 times 3 is definitely 12. So this is a perfect square. So how do we factor that? Well, what we can do now that we know it's a perfect square is we can say that the first thing has to be 2x, the second thing has to be 3, and in order for it to be a minus sign right here, it's got to be 2x minus 3, the quantity squared. Last problem. So start off with this first term. Is that perfect square? Well, sure. 16x squared is a perfect square. When you square root it, you get 4x. How about the square root of 1? Well, that's 1. Is 16 2 times 4x plus 1? Or times 4x times 1? No. That's not 16x. This is not a perfect square. And unless you can think of factors of 16 that add up to 16, okay, this is actually prime. And there are no factors of 16 that add up to 16. 8 times 8 is 64, kids. Don't say 8 times 8. That's 8 plus 8. Remember what factors means. Hopefully it's not too lengthy. I do love me some factoring. Hop onto IXL. Remember, it's double A, like the batteries. See you guys in class.